Good day, everyone. So welcome again to my class. So this time around, we do a short course video about ANOVA 1. What does ANOVA 1 mean? So this is me again. These are all my particulars. Again, my name is Hadi. This is my office and this is my extension. Come whenever you want to have consultation during the consultation hours. ANOVA 1 way is called Fdistribution because in this statistical analysis, we are not going to find T0 or Z0 anymore. We are going to find, you can say it, F0. It is created by a person called Dr. Fisher during the booming industry in the US. So he created this to compare between groups. What do I mean by compare between groups? Here is a slide. Here is a question. So previously we have, let's give some color. Let's say red. Yeah, red. Let's say we are comparing between two groups. Let's increase the size. Two groups. When we want to compare two groups, either H1, mu1 the same as mu2, mu1 is not equal to mu2. And with this, either standard deviation or variance given or not given, then we decided to use a population test or normal distribution test or Z test, or we use T test. If we have a lot of groups, for example, mu1 and mu2 and mu3 and mu more and mu infinity, it's a hassle to do mu1, mu2, mu1, mu3, mu1, mu4, so on and so forth. It's a hassle. So what we'll do is, we just have a new hypothesis. The new hypothesis looks like this. For ANOVA 1 way, blue pen, ANOVA 1 way, your hypothesis 0 will be all means are the same. Hypothesis 1 means at least one is different. Okay, what is ANOVA, by the way? Now let's take a look at the word ANOVA. ANOVA. ANOVA means okay, let's reduce the font. Analysis of variances. Okay, because we are going to take a look at variances for each group. That's why we name it analysis of variances. Okay, so when we want to have more than two groups, we call it more than two levels, right? We call it group of levels. So it is called ANOVA, and it's developed by Dr. Fisher in the early 20s during the agricultural booming in the US, and it is used extensively in any industrial experiment, in any engineering experiment, whereby you are going to find or search which design is the best between all the groups. Let's say you have design 1, design 2, design 3, design 4. Which one of these is the best? It's hard to do engineering analysis for all of these designs. But if you do statistical analysis, you will have a shortcut way to find what is the best design, or they are all the same. Okay? In this case, I bring in my dear friend Miss Katy Perry, and she is an engineer, a cotton engineer, whereby she has fields, acres and acres of cotton, and with this cotton she makes shirt, right? Make shirt. So in terms of shirt quality, usually we use strength. We try to tear them apart and see the one that defy the strength test is the strongest among them. Okay, so how she's going to do this? So she used cotton weight percentage, right? So she has 5 cotton weight percentage. So in ANOVA, this means level, level. And the symbol is A, and we have 5 of them, right? 15% cotton, 20% cotton, 25% cotton, 30% cotton, and 35% of cotton. And we test them, we tear them apart. For each of the tests, we do 5 repetition, as you can see here. So all together, we have around 25 runs. We call it runs. Some textbooks call it experiment. Up to you. Whatever rocks your world. So I call it runs. Okay, 25 runs. For each of these runs, you have different cotton percentage, and the observation will be the strength. Strength. So let's go back. What do we have? We have A, or levels, 5 levels. We do it 5 replicates of 5 times per level. So 5 times 5 is 25. We run in random orders and we have the results. So this is the case study and summary, right? So she choose 15, 20, 25, 30, 35% because she knows from previous works 10% to 40% would give you a very good strength, and this is her hypothesis. Strength affected by the weight percentage cotton used in the blend of material for the fiber. The more cotton I put, the stronger it is. Alright. Okay. So in this case, we cannot use t-test again because it is very, very it is very it's take a long time to finish. You need to compare groups per groups. For example, 15%, mu of 15% compare with mu of 20%, mu 15% compare with mu 25%, which will take you a lot of time. So we do ANOVA one way. Here are the formulas. How many of them? 1, 2, 3, 4, 5, 6, 4, 5, 6, 7, 8, and 9. You have 9 equations in this table, which will be provided in your final exam, and you can use it to find your F0. What should we do with with this F0? We need to refer it to the table. So here is your table. If F0 is bigger than this, so usually use 5%, right? 5% alpha, and this is the degree of freedom of level. This one is degree of freedom of error. Okay, take note. In the table, you have V1 and V2. What are these? Wait for the end of the slides. I'll tell you what these are. If this is the case, right? Let's do another one. This one is H0 accept, just like the distribution, right? This is 5%. If your F0 red color here, green color here. This is H1 accept. This one means H0 accept. Same thing as t-test and z-test, right? Now here are the result of observed tensile strength. It is given in the unit of pound per square inch. In my question, it doesn't matter what kind of question there are, what kind of observations that you see. What you want is these data, right? These data. Let's back up for a bit. Let's write by steps. Steps number 1. ST1, find the total. ST2, find the average per group, per level, right? Then this is called S3. What we call this as grand total. Grand total, right? And this is grand average. So all this, how do you find grand average? 9.8 plus 7, what's that? 15. 4 plus 17.6 plus 21.6 plus 10.8 divided by 5, you'll get this result, 15.04. That is the grand average. The calculation is lengthy but not that hard. What you need to note, I'm going to write here in red color. The main note is, number 1, all values are positive. What's number 2? Simple. H0 or H1. Alright. The equation goes as such. You have SST for total. Alright. Let's see. Alright, and then you have SS treatment. So one textbook use treatments, one textbook use level. Right? I use level. And the last one SSE for error. The equation are given as such. So here is the equation for SST or SS total. You have two summation. You can see here is I from the first number, J from the first number, right? And this is till A till N. Right, we have A equals to 5, N equals to 5. Let's back up a bit. Now, what does these two means? That means you need to sum all the i's and all the j's. What is I and j? I and j is this one. If you break this into axis, this is x-axis, this is y-axis. So you have this as I, you have this as j, right? I and j, that means you need to go one by one. This value, this value, these values until the end, right? Until the end. That is why you see, you need to square them and plus them. Square them first, then plus them. So you have 7, 7, 15, and the dot, 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 and 15, and 11. Where do we get this? Look back here. There, you have 7 squared, 7 squared, 15 squared, 11 squared, 9 squared, then 12 squared, 17 squared, 12 squared, 18 squared, 18 squared, 14 squared, 18 squared, 18 squared, 19 squared, 19 squared, plus 19 squared, 25 squared, 22 squared, plus 19 squared, plus 23 squared, plus 7 squared, plus 10 squared, plus 11 squared, plus 15 squared, plus 11 squared. And you will get your total, right? This will be your grand total. This will be your samples. And you have a positive value result, 636.96. For the treatment, let's use another color. Let's use green. So here is your repetition, right? Here is your I to A. This one is level. It means you have 5 levels. For each of this row, you see here I and dot. That means if you have a table that works like this, you go for each of the I. What is I? X-axis. What is X-axis? Rows. Right? X-axis. Okay, rows. So here you see, what is this? 49 and dot, 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 and 54. Where do we get this? Go back to this one. You'll see your total there. There. 49 squared plus 72 squared plus 82 squared plus 108 squared plus 54 squared. And you write it down. Sorry, I'm going too fast. Right? You can write the dot, dot, dot there to simplify your calculation, minus the grand total and the sample. And then you have your positive value. Right, let's go to light blue color for error. If you have managed to calculate perfectly SST or total and SS level or treatment, you also have a positive value for error. SSR. What is SS? Excellent question. I heard somebody ask at the back of the video there. SS is sum, of squares. What is sum of squares? This, right? The variance. Right? Excellent segue. Now, once you have done SSE, let's go back to the calculation. You have done SST, you have done SSE and SS treatment. What about the degree of freedom? The degree of freedom for what is this? For level is 5 minus 1. This one is 25 minus 5. And this is 25 minus 1, which is 24. And this one is 20. This one is 4. Right? So go back here. Next, you need to calculate the MS treatment. Right? MS treatment is given by MS. What is MS? Mean square. MS is for level, is SS level divided by the degree of freedom for level, which is 5 minus 1. Right? For MSE, for error, so you need to use SS error minus N minus A, which is 20. Right? So this is 20, this is 4, this is this is SS level or treatment, SS error. Right? And then the last one, F0. This is your MS treatment. Again, treatment or level, and this MS error. You have a value. F0 equals to 14.76. What do we need to do with this? Of course, to the table. Right, to the table. Now, let's go to the table. I don't have it here, so that means I need to go to my times. So, let's see. This is the formula sheet, and this is the table. Take a look at page number 3. Okay, begin with page number 3 until page towards the end of the page is about F, critical value of F. Therefore, this is for F distribution, and we are talking about ANOVA one way or two ways, right? This is ANOVA one way. Let's begin with 5% significant level. Alpha equals to 5, right? Alpha equals to 5. There, right? Alpha equals to 5. Sorry. The equation gives as such: F alpha A minus 1 N minus A, right? So this is the degree of freedom for level, degree of freedom for error, and this is 5%. So the whole equation will be F 5% 4, 20. Another color. This is V1, this is V2. So V1 is for degree of freedom of level, V2 is the degree of freedom for error. So let's go to our statistical table. This is your V1 above here, this is your V2. V1 is 4, V2 is 20. Again, V1 is 4, V2 is 20, and if you cross them, you get 2.87. Under 4, V1, under V2 20, 2.87. Let's go back to our lecture. Our result was this, 420. Again, this is V1, V2, and 2.87. Let's take a green. So 2.87 is less than 14 point, what is it again? 76. Therefore, null hypothesis is rejected and you must add one more mark. What are they, or what is it? Null hypothesis rejected, that means H1 is accepted. It also means the strength of shirts, are different. Alright, definition of strength different. That means you need to find which one is the best. When you have H1 accepted, then you need to do an extra thing called the estimate of overall means and treatment effects. Okay. Alright. So this is the graph distribution for the F0. As you can see, for F0 is very far towards the right side, and it's always, let's make it big, positive value. Right? Positive value. Let's say if H0 is accepted. Let's go back to this page. If H0 is accepted, what does it mean for these shirts? It means that none of these shirts are different. Any kind of cotton weight percentage will give you a similar strength. If you decided to choose one for production, and maybe the more cotton that you have, the higher its price, then choose the cheapest one, which is 15% of cotton weight. If H1 is accepted, you need to do the estimate of overall means. To do this is very simple. Here, is the average. This one is the row average. Row average, and this is the grand average. Alright, the one that you have calculated just now. Let's go back to that slide. There. Oh, sorry. Something wrong with my iPad. Okay. This number minus the grand. 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 So you have 5 levels. So you have 5 values. Alright. This is exciting. Okay. Why it's exciting? First, this is for 15% cotton. This is 20, 25, 30, and 35%. The result, you need to take a look at 2 things. Number 1, positive and negative value. Positive means going up, that means good yield or good output. Negative means not so good output or bad yield. But again, this depends on your case. In this case, we want to see strength. That means positive value will give you a good strength. Negative value will give you a negative strength. Number 2, magnitude determines the main level. In this case, have a look. Out of all this, you can see that you have 2 negative and 3 positive. That means this 3 will give you good yield, good strength. This one will be less strength, and this one as well. Less strength. In order for you to choose the best, it will be this number, 30%. 30% will be the best. If you decided to choose the one that has saved the cost, again, will be this one, 15, 20. 20% is your least strength, and you can also choose 2.56 for the middle one. So if you are looking at the best, then 30% is the best in the positive value or the good yield. If you're looking for the cheapest one, it will be 20% at the lowest positive yield. Right, so that is what ANOVA one is. Fdistribution. Thank you for watching. I look forward for you to watch my other videos.